So here we have a question from RC circuit. In this circuit, you can see we have two switches K and S. Initially, it is given at the switch K is open and S is closed at t equal to 0, and the capacitors were initially uncharged. First, we need to find the current through the battery as a function of time. Then if at t equal to 3 RC, the switch K is closed and the switch S is opened simultaneously, we need to find the total heat loss in the resistors in a very long time. So let's see how we can solve this problem. So in the first case, the switch K was opened. So I have removed this particular branch where the switch K was present. That is of no use to us now. So switch S is closed at t equal to 0. Now suppose at any time t, the charge on the capacitor is suppose Q, and on this capacitor also I can take the same charge because you can see that these two circuits are connected in parallel. These RC branches are connected in parallel and the values of resistance and capacitances are also same. So by symmetry, I can say that the charge on both the capacitors will be same at any instant. Similarly, if current through this upper branch is I at any time, then the current through this lower branch will also be I at any time t. So the current through the battery is going to be 2I. Now, what is the value of I? Since this I current is going through the capacitor and it has a charge Q, so I can write the value of current I will be dq by dt. Right. Now, if I write the equation of KVL in this outer loop, you can see this loop, the battery, the resistance R, and any one particular branch you can take over here. So this is the complete loop in which I am writing the KVL. So using KVL, I'll get E minus of 2I times of R. So here there is a drop of 2I current into resistor R. Then across this resistance R, again there will be a drop. We are going from positive to the negative side. So there is a drop of I into R. Then if we move across the capacitor, there will be again a drop of minus of charge Q by C. And we'll come back to the same point, starting point. So this will be equal to 0. So from here, I can write that EC minus Q divided by C will be equal to 3IR, and 3RI can be written as dQ by dt. So if we rearrange this expression, dQ divided by EC minus Q will be equal to dt by 3RC. So if we integrate this expression on both sides at t equal to 0, the charge on this capacitor plate, I'm writing the equation on this positive plate. So initially the charge was 0. At any time t, the charge becomes Q. So this will be negative of ln of EC minus Q. So first we'll put the value of Q. Then if you put 0, you will be left with EC. So divided by EC will be equal to T by 3RC. Right. So if you rearrange this expression, you will finally get Q equal to EC times of 1 minus e power minus 3 minus of T by 3RC. So this will be the charge on the capacitor at any time T. So what is the current through the capacitor? Current is simply dq by dt. So if I differentiate this equation, it will be EC divided by 3RC into e power of minus t by 3RC. So this C capacitance terms gets cancelled out. It will be E by 3R, e power of minus t by 3RC. So what is the current through the battery? If we need the current through the battery, it is twice the current through the capacitor. So 2E by 3R and into e power minus t by 3RC. So this is the current through the battery. In the second part, we are needed that if I close the switch K at t equal to 3RC and open the switch S at t equal to 3RC, what will be the total heat loss? So let us first find that at t equal to 3RC, what is the charge on the capacitors? So in this expression, you just put the value of t equal to 3RC. The charge will be EC times of 1 minus 1 by E. Right. So if you redraw this circuit, you can see that it's in any one particular capacitor branch. So this is the one branch and this is our second capacitor branch. So if you close the switch K, so this part will be short circuited. And since we have opened the switch S, there will be no current through the battery and resistor. So in this particular resistor which is connected in series with the battery, in this resistor there will be no current and no heat loss will take place in this resistor after we interchange the switches. So now the switch K is closed and the switch S is open. So after the switch S is open, there will be no current in this resistor capital R connected with the battery. So there will be no heat loss in this particular resistor. But just when we changed this switch, this circuit came into existence at t equal to 3 RC. So at this particular instant, the charge on the capacitor was Q naught. So I'm calling this particular value as Q naught. Let us say that this charge is Q naught. So the charge on the capacitors was Q naught. Now you can see that if I close the switch K present here, if I close this switch, it will become a discharging circuit. This capacitor will discharge through this path and this particular capacitor will discharge through this path. And the final charges on the capacitors will become zero. Right. So when the steady state is reached for t tending to infinity after a very long time, the final charges on capacitors are going to be zero. Final charges will be zero. So we can see that the initial energy which was present in the capacitor, what is the energy that was present over here in the capacitor? Simply Q naught square by 2C. And in this capacitor also the energy is Q naught square by 2C. So both these energies will be lost in the resistor, because at infinite time when the steady state is reached, there will be no final charges on the capacitor. They will be completely discharged. So the initial energy that was present in the capacitor, that is the total energy lost in the resistors. So total energy lost in resistor, total energy lost in resistors is equal to basically the total energy initially present in the capacitors. So in any one capacitor it is Q naught square by 2C. In both the capacitors it is same. So I'm simply multiplying by 2. So we know the value of Q naught. So this value will be E square into C times of 1 minus 1 by E whole square. So this will be the total energy lost in the capacitor. So in the resistors.